In this video, we are going to learn about special right triangles. So our two special right triangles are 45, 45, 90 and 30, 60, 90. And so these are patterns that help us solve triangles with these types of angles. So when we have a 45, 45, 90 triangle, 45, 45, 90 means that two angles are congruent, meaning two sides are congruent. So this is going to follow the pattern of side, there's a little s here, but I'm going to make it bigger, side, side, and then the side across from the right angle is the ratio of side root 2. If we have a 30, 60, 90 triangle, the side across from the 30 is going to represent our side. The side across from the 60 is side times root 3, and the side across from the 90 is going to be 2 times side. And so we're going to use these patterns to help us solve problems involving special right triangles. So if you look at this, I see I have a 30-degree angle here. So that means I have 60, 30, 60, 90. So that's going to follow the ratio of side root 3, 2 times side. So my side across from my 30 is 15. So that means the side across from my 60 is going to be 15 root 3. And the side across from the 90 is 2 times 15, which is going to be 30. Here we also have a 30, 60, 90 triangle. So across from my 30 is side. Across from my 60 is side root 3. And across from my 90 is 2 times side. So in this case, they're telling me that 5 root 3 is the same as side root 3. So I can see that since I have a root 3 on both sides, that those will go away, and that my side is going to be equal to 5. So that means my x side here will be 5, and my y side will be 2 times 5, which is 10. Here we have a 45, 45, 90 triangle. So in a 45, 45, 90 triangle, my two legs are congruent. So that means since this is 5, P is also 5. Then the side across is side times root 2. So if the side is 5, this would be 5 root 2. All right, here we also have 45, 45, 90. So I know these two are congruent, and it's going to follow the pattern of side, side, side root 2. So if 13 root 2 is equal to side root 2, that means that since I have a root 2 here on both sides, that my side is going to equal 13. So this is going to be 13, and this is going to be 13. All right, here they tell you I have a 60-degree angle, so I know this is 30. So my pattern is side, side root 3, 2 side. Because again, the side across from the 30 is always the s, and then the side across from the 60 is always the s root 3. So if 20 is equal to s to 2s, that means s would equal 10. So that means this side, my x side would be 10, and my y side would be 10 root 3. All right, now we're going to get a little trickier. So they give me the 30-degree side, and they're telling me the 60-degree side is 12. So 12 is going to be equal to s root 3, because this guy's s and this guy's 2s. So if I know s root 3 is equal to 12, and I want to solve for s, that means I would, since this is multiplication, I would divide. Now, I cannot divide 12 by root 3 because 12 is a whole number and root 3 is a radical number. So my side is just going to be 12 root 3. And so that's when it's going to be my a value. My b value is 2 times side. So that's going to be 2 times 12 over root 3. So we multiply a whole number by a fraction. We multiply the tops, we multiply the bottom. So I end up with 24 over root 3. And so those are all my examples of how we use special right triangles. The last thing we're going to review today is SohCahToa, which is something we talked about in geometry. So sine is so. So when we talk about sine, we're talking about so. We're going to talk about opposite over hypotenuse. When we talk about we're going to talk about cosine, which is adjacent over hypotenuse. When we talk about toa, we're going to talk about tangent, which is opposite over adjacent. So what does all that mean? Well, those are all relationship to the side. So if we're talking about angle A in this case, which is right here, my side across from angle A, or the 5, this would be my opposite side. My side adjacent to A is 12. And then my hypotenuse is always across from my right angle. And my hypotenuse is also always my longest side. So opposite, adjacent. So when we're talking about what is the sine of A, that is my opposite over my hypotenuse, so that is going to be 5/13. We're talking about the cosine, that would be my adjacent over my hypotenuse, so that would be 12/13. My tangent is my opposite over my adjacent, which would be 5/12. Now we're going to talk more about SohCahToa later with all 6 trig functions, not just 3 trig functions, but this is a little bit of an intro.